the other I call also switch to, so that you can turn, say how much gain you are going to add. So let's say add here, some gain, you can add it. Then there's a motor here, will drive the beam. Okay, let me just give you another view here. And again, you can see the, if you read carefully, I don't know if you can see it or not, there's a strain rate switch, there's accelerometers. If we look at this one here, this we call accelerometers. In Chinese called 加速规. These are the accelerometers here, as accelerometers, and we have strain gauge in here. It's the strain rate gauge and strain gauge are in here. And there's this is another controller, and there's a tachometer here. This is tachometer switch here. Again, there's, if you look at carefully here, you can see there's a 5, 5, 6, 2, 6, and this is all the gain values you can add to your output. All right, and let me show you this. But this is, let me see. It's very the voice is very low, but I can explain to you here. If you look at this carefully. Okay, you see, just turn off the strain gauge. So turn on the strain gauge, or turn off the strain gauge. This is the switch. And then if you look at this one here, this is my hand. And if we will show you how they vibrate. Just turn on the strain gauge will improve the motion, but you can see it. I think the you look at now when you come back. Okay. So large motion, and then you can see that you control the tip motion. That's what it is. But this is a student project. This is senior student project. When I was in NASA, I did a senior student project for them to do. And this is another project. This is a bigger project. This is not the student project. And you can see me, I'm operating the analog computer. But you don't see this is computer anymore, so I'm not going to talk about this much. There's no analog computer anymore in NASA too. That time, because computer, we don't have like notebook. All the computers are so huge, so it's not fast enough to compute the game. It's not fast enough to operate. So you have to rely on the analog computer. Anybody heard about analog computer? No, right? Well, the digital sense is also card with some power, but this is analog computer. They have an integrator, they have differentiator too, but this is all use the tube. It's a vacuum tube, it's kind of tube, so you don't see those anymore. But this is that time in '80s, and we still use that. This is another design for pointing control. If you have a flexible beam on one side and then another flexible beam in another side, then how can you control the two beams at the same time, the same move the angles? There's two models here, one model on the right hand side, one model on the left hand side. So we have a two input, but we have each beam has at least 4 or 5 outputs. So we have like 7 to 8 outputs and 2 input to control. And this is the, I'm not going to show you this because that's too much. And this is with translation motion, rotational and translation motion too. There's a lot of going on here. Maybe I can show you this one and see what happens. And see if I can. I don't think it's. You know. This is use the camera. This is not digital camera. This is the analog camera, and so you have called VHS to shoot it. And just show you what is the amplifier. There's the amplifier. There's also some look at this. If you don't have the control, you can see that the beam is moving around. It will take a few seconds to really them out by the air, by aerodynamics. Move again, like that, right? So that's no control, just move the car, translational motion, move the car. That's what's going on. It's no control, and if you have something in space like this, then you cannot fight. There's no way to fight because you cannot point to any target. If you have a flexible beam like that, you cannot point to any target. But this kind of movie in the 80s, it's very famous, you know, because this is the way show NASA how to do the control. So we call flexibility control, feedback control. See that we control. This control using translational motion control. It's not using torque. The translation motion control. Look at that, right? It looks. If you have a control, if you don't have a control, and there's the differences. Even this is flexible. Try and model. Okay, now I turn this off because I don't want to talk too much about this. Well, there are many different control systems we designed in NASA for all kind of missions. And this is one other the systems called suspension systems. And this one here, the suspension system, we call passive disk, because what we try to do is to balance this system, this mass, we call passive particles, so that it behaves like in space. Your counterbalance